Good afternoon, all of you. I'm Mohan. I would like to extend my sincere thanks to the organizer for inviting me in this forum to share our good work on reconfigurable robotics. I'm highly excited to share and provide an insight into our research, development, and enterprise activities at SUTD in the area of transforming robots. Reconfigurable robots are nothing but robots with the ability to shapeshift. To me, they are nothing more than Optimus Prime and Bumblebee from the movie Transformer. The only big difference is that the robots that we develop at the Road Lab in SUTD takes on jobs that are dull, dirty, and dangerous, but not go to fight a war. So we are making a huge difference in about 10 plus applications spanning construction, healthcare, maintenance, in marine, aerospace industry, in education and beyond. So we have over 30 different robots. Each one have transformative properties. It could be only autonomy and the level of autonomy, or it can be the entire robot changing from one form to another with or without human intervention. So such reconfigurable robots have immense potential to extend the power of fixed form platforms, because they can go into spaces impossible for traditional robots. They can handle tasks, especially multiple tasks, which fixed form robots cannot take. And this is even more critical with cost sensitive industry. Imagine when somebody have to transform a manual task into a robotic task, the company have to pay capital for installation and use. If we are going to offer them a robot that can do multiple tasks, it's going to be very attractive for them. And we have witnessed that in many applications. So I will share with you some of our robots, not all of them, to give a quick insight. The very first robot that I want to introduce is Tetro. It's a Tetris-inspired floor cleaning robot. How many of you are using floor cleaning robot or have seen floor cleaning robot working in homes? Please raise up your hand. Yeah. So is many of you here, right? So here we are developing robots that take inspiration from Tetris that can change to one of 7 forms. Most commercial robots come in forms like this, but you can see it has a lot of issues accessing places, right? Especially when it comes to tight spaces. It has challenges. And what we did was we took a far field inspiration in the form of Tetris and made it into a robot. So now this Tetris robot can detect and can assume form factor so as to maximize area coverage. So we have about 8 different variants of this robot. One with purely bump sensor, LiDARs, ultrasonic sensor, IMU, wheel encoder, to ones with 3D LiDARs, right, with infrared cameras, with cameras on board, right, from simple to complex in terms of sensor sophistication, also in terms of cleaning payload, vacuuming to mopping to scrubbing, small and big. So we also ran a performance comparison of our robot with other robots in the market. So just because this commercial robot cannot move to the other side, the area covered as observed by an overhead camera is less than 30%. Whereas with our Tetris robot, it can assume a shape of eye, move over to the other side, cover and clean the area. In this case, over 90%. Right, so again, to achieve that, the robot need not have sophisticated autonomy or perception. It's simply the ability to shapeshift, right? So then, with higher order sensors, the robot can classify objects and can assume different speed, different form factor to access the places. So we have developed a number of applications with this category of Tetris-inspired platform, the Tetro. So it's not just about floor cleaning robots. Working with Tetro, we engage as a design university, the end users, cleaning service companies, cleaning equipment manufacturers, robotic companies in the space, cleaning professionals themselves, talking to many of them. And we found cleaning floor is harder. However, there are hundreds of companies making floor cleaning robots in this particular space. But when it comes to staircase, there is nobody making robots for the market. And it's a challenging and open problem. So we took on staircase cleaning as a challenge. So we now have 3 different variants of robot developed. One that's capable of ascending the staircase autonomously. One that descends, and a third variant that can do both. So the platform can calibrate to different staircase height and width. The robot generates control primitives to achieve climbing. So it can avoid any obstacle, static or dynamic, while climbing the staircase. Again, the robot is equipped with capabilities to autonomously access multiple stories. So we ran trials together with Tampines Town Council and EM Services. We got very valuable feedback. So at the moment, we are refining the system, especially with respect to safety. So how can we ensure complete safety for a platform like this when there is no commercial precedence out there? So we are looking at safety aspects of the robot mechanisms that can ensure 100% safety, right? Because autonomy is very exciting with this platform, because the robot not only maintains a 2D map of the space, a 3D map of the space, and also there is variation in the z-axis as the robot climbs and move from one floor to another. So we are also now experimenting new application for the robot beyond cleaning in goods moving. So staircase is always present in every building. Why not use staircase to move goods with platforms like that? The robot need not go left to right, but simply climb up to move goods, right? And it's also capable of cleaning. So we also have vertical robots that can clean facades. So in this particular case, the robot clean indoor facades, not high-rise facades. So we took on the challenge as a trade-off with the amount of logistics that is needed. So the robot solves a very niche problem. With commercial robots, they can clean a single panel, but robots cannot move between panel because of the frame that separates the panel. So with our Mantis, the robot can move between panel. The robot uses impeller to adhere to the wall, and they have the dry mop nanofiber cloth to clean. So we leverage to support ST Aerospace with a robot for inspection of exterior surface of the aircraft. So that was a leverage project where ST Aerospace invested in us to develop this capability. So it's not just that. We have large vehicle platforms too. So we are developing an autonomous pavement sweeping robot, Pantera. So the robot, we have two variants. One has the ability to compress and expand to adapt to the varying width of pavements. So the robot can compress when there is a wheelchair user passing, a cyclist passing, or people passing, and it can expand to the full width when nobody is around to be adaptive. Also, we have a second variant which is holonomic, which recently took the T1 test, and we have started trials at the JLG, Jurong Lake Garden. So we are working together with NParks, and we have been deploying it since early this month. And we'll be continuing our trials with the Jurong Lake Garden and with a few other partners as well. So there are two variants, one with the compress expand ability, and another is holonomic. But again, in this case, it's vehicle class outdoor cleaning system. So it's not just about cleaning we deal with. So we have goods moving robot too. And this is an exciting project where another aspect of reconfigurability can be observed. Our hospitals in Singapore are big supporters of robots, thanks to them. Every hospital have hundreds of robots, right? So they are in the front line of any new challenge that emerge in the case of big adoption of robots. With Changi General Hospital, again, they have close to 200 robots doing goods moving, bringing trolleys, handling linen cloths, food, medical logistics, and on. It's very good. But they have so many different type of robots. Small robot for small material handling, large robot for large material handling. And these have given rise to so many different type of robots. So they approached us to develop a new type of cellular robot for goods handling, where when there is small goods that needed to be handled, one unit can be used. When there is a need for larger good to handle, one can simply put 2, 3, or 4 robots together. So we developed WASP, a new category of robot. So the platform can lift objects from the top, it can tow objects, tow trolleys. We had a 6-month pilot period together with Changi General Hospital at the hospital, integrating with RMF and trialing, with wireless charging as well, in partnership with a local startup. So when a larger payload has to be carried, 2 robots can be connected together. So at the moment, the 2 robots connection requires manual intervention. So we have an ongoing work to do this automatically, where one can say WASP 12, go and connect with WASP 7. So WAS12 will seek after WAS7 and automatically dock with each other. So in this case, the capacity is significantly increased. So we also trialed other applications since we already successfully finished the task of goods moving, and there is an enthusiastic bunch of engineers. So we went and explored other applications like wall cleaning, even patient handling. So patient can be ported from one place to another, right? So this can be from the ground and beyond, just to prove the versatility of the base platform. Yeah. So we had a by-arm system implemented on the robot to scale further. So again, moving from many wheeled robots, I also want to introduce one of a cool work that we developed with the Tamasak lab at SUTD, funded by the Ministry of Defense. Here we developed a transforming robot for an urban reconnaissance mission, a security mission. The background is this: an urban building is held hostage by hostile forces. Security personnel has to get information from the building. The traditional approach is security personnel themselves moving into the building, which is very dangerous for them. There has been recent products like throwable cameras which can be thrown in to see what's happening, but cameras cannot move. There are some use of robots, but many of these robots are big, bulky, difficult to port, easily observable. So MINDEF posed a challenge. Can you develop a transforming robot that can crawl, roll, and climb wall with a rolling diameter of less than 10 centimeters? Also be autonomous, also capable of working as a team. Yeah, we took on the challenge and we delivered a robot. But when we started, there was no precedence at all for a robot that can crawl, roll, and climb wall. We looked to nature for inspiration. And that's when we came across Cebranus reichenbergii, a kind of huntsman spider only found in the deserts of Morocco, nowhere else. Because it's an endangered species, we could not get the spider. We got a lot of videos of the spider. We observed. This is not animated video. This is a real video of the spider. So the spider can crawl, it can roll, and it can climb wall. A perfect precedence for us to study. So we studied again and we developed a robot that mimic the locomotion of the spider. So with climbing, we have nanomaterial skin in the underbelly that enable the robot to climb. And the same robot is capable of crawling and rolling. So it was a 4-year project. We did over 30 different challenge statements that we met, like energy-aware behavior, where the robot stayed alive for 21 days, intermittent operation, coordination with a team of 10 other robots, and many more. The project was successful, and we were able to meet all the different requirements. So it's not just we build robots in our lab. We do a very important thing for proliferation of robots in a big way. We work very closely with urban planners, architects, and interior designers to make buildings robot-friendly. That is very, very important if we want to scale up robots. And this is not using passive components. This is not using active components, but purely passive interior design. Passive principles in urban design. And we can increase. For example, observability is a criteria. We all know that when there are no features in the environment, it's going to be difficult for the robot to navigate, right? So how can architects design inbuilt principles when a new building is constructed or evolve an existing building so that it becomes easy for robots, right? Going back to the goods moving example, if hospitals are using close to 200 robots, then robots become a critical stakeholder to consider, right? So here we develop principles. So we have practicing architects in our team, urban planners in our team who contribute and develop these principles. So we contributed to the BCA's Design for Maintainability guidebook. Working closely with BCA, we now have a new chapter on robotics and how building owners can evolve their existing building or construct new buildings considering robots of the future. And this is going to be a very, very important topic. SUTD being the second university in Singapore to host architecture school, we also introduce robotics to architects because they are going to make our life easy for our robots. Also, we work with a number of partners. They make our robots meaningful. In fact, we actually meet a company every week. So this can be a building owner, it can be a service company that delivers services to introduce our robot. Then they come up with problem statement or evolve our robot or pilot our robot in their place. So this helps us to translate our robot to the industry. And you can see there's a whole spectrum of companies where we have trialed or piloted our robots. Also, industry invests in us. Industry come to us. with a problem statement. They invest in us to solve a problem. So this can be MNC companies like Toyota, Rosen-Schwarz. It can be Singapore large enterprises like ST, also small, medium enterprises and startups that come to us and we develop through the research collaboration agreement. And we have successfully transitioned over 10 licenses, technology licenses to commercial companies so far, which has gone to products, and we see them also going global at the moment. Beyond that, my lab has 4 startups that have been inspired from my lab. The more mature of the startup is LionsBot. So LionsBot is now 6 years old. I'm a co-founder of the company. The company is, by different market study, 3rd largest in manufacturing cleaning robots. We have over 2,000 robots now deployed in 30 countries. In Singapore, we make our robots. Every one of our robot is manufactured in Singapore and shipped out to these 30 countries. We have 3 product class, so I will be introducing, in the interest of time, just the R3 class, which is a hot seller. So LionsBot, with over 300 staff employed locally, we want to be an example of how a robotic company can design and manufacture robots here. So we want to see the ecosystem grow up, and we want to be a positive example and share our successes with other robotic companies in different sectors. So the second company that I've been inspired from my lab is Motor Robotics. Motor Robotics is in the area of pest control, targeting mosquitoes, rodents, and snakes. Singapore, being a tropical country, have big issue with these pests. However, at the moment, all work are completely manual. And these are jobs that nobody want to do. Nobody want to go after mosquitoes and chase them. And it's not efficient to put people to chase after mosquitoes. So here we have developed different class of robots that target pest control, and we have commercially deployed robots as well. So the company has 3 classes of robots, one targeting mosquito control, another with rodents, and the third with snakes. If you are from NUS, you may have seen this robot running in the Techno Edge canteen every day, running around and catching mosquito. So Techno Edge canteen is one place where both LionsBot robot as well as Dragonfly from Moto are deployed. One cleaning floor, another catching mosquito. So Koi is a residential equivalent. It looks like a floor cleaning robot, but what it does is it attracts mosquitoes, insects, trap them. So Naja is a snake repellent robot. So again, Moto is opening new market where robots have never been used before. Mosquito control and snake control have never witnessed use of robots, and now Moto is breaking open new markets, new countries and application. So Oceania is a third company inspired from my lab. Oceania design and manufacture robots for marine maintenance, especially for water and abrasive blasting. That is very much needed in shipyards with marine contractors to remove biofoul, remove paint. So this is a niche industry where often robots are treated as equipment on rentals. These work processes are at times dangerous because of the water pressure or abrasive pressure that they have to deal with. These robots uses magnet in their underbelly to attach themselves to the surface of the ship hull, move, cover, clean, remove biofoul, remove paint. This was on an oil rig at Keppel Shipyard. And you can see how dirty and ergonomically unfriendly the place become. So these are jobs perfectly suited for robots, and more and more robots are coming to take on jobs such as these. So with these developments, we were looking at what is the next industry. And what immediately came to us is, the source of all these successes are people. And people have to be trained in robotics. So let's go and make educational robots. So the last company, our more recent company, is Viva Robotics, that design and manufacture educational robots. The company leveraged and licensed the Tetris robot that you saw in the first video. So they have been selling the robots in the market for the last over 1 year. We have over 200 robots sold in 12 countries. So that's a perfect validation. So we recently closed our seed round, and we are expanding to hit our 10,000 units. A short video. So again, we see the robot used in universities, high schools, polytechnics, kindergarten, enrichment centers in the US, in Europe, in Africa. We have our robots in Central Africa Republic. We have it in tiny Bermuda. And we have it in different parts of Asia, Vietnam, China, India, Indonesia, Japan. Again, it's the very first Tetris-inspired robot for education. It offers modularity in learning, where the robot can be broken from a single unit when one-to-one learning happens, and units can be combined together, where it can be 4 block, 5 block, 6 block combined together to take on a task. So the platform is holonomic, and it supports simple sensors to complex sensors, ROS enabled. We have a successful run of ROS bootcamp 2-3 months ago, and we will have one for today. Again, competitions. So the robot is becoming a favorite platform, standard platform for competition. 2 months ago, Science Center announced that this robot would form a new third category for the National Robotic Competition, the largest robotic competition organized in Singapore. The same is true with competitions happening around the world. A RoboROS competition conducted at the Zhejiang University in China used the robot as a standard platform. We will soon have a RoboROS India hosted by Amrita University, where we will see over 300 students participating. So these were students from junior college who developed application for tennis ball recovery. So this was an outcome from a design thinking course, where students were given the robot and they have to solve a problem. 2 of the team members were tennis players. They quickly coded the robot to take on the task. So WIFA is now in all continents except Antarctica. Our idea is now to scale up with the new growth. And one thing you can see with all the robots I presented, there is a commonality. All robots are powered by ROS. So ROS is a big enabler for robots that span from home cleaning to wall cleaning to ship cleaning to logistics to education to catching mosquitoes. So we really want to be part of the community, collaborate with all wherever possible, and to contribute to the ROS community, to the larger ROS community in every way possible. Thank you. I'm open for all engagements. I'm happy to talk to you. Yeah. Thank you again for the opportunity to share our work.